right, so we're doing our mid-unit assessment review for our trigonometry here. So you can obviously have your unit circle next to you. I don't expect you to have it memorized. I personally have it burned into my memory from doing trig a lot of times. So angle theta satisfies cosine of theta equals 0. That means that the x-coordinate is equal to 0. So if I think about the unit circle, I'm either up here or down here. So I'm either at 0 comma 1 or 0 comma negative 1. And so that would mean that if this is 0, that means I'm either a quarter circle or 3/4 of a circle. Okay? Half a circle is pi, so a quarter circle is pi over 2. The other option is this one down here on the bottom. Between 1 pi and 2 pi is 1.5 pi. Because 3 over 2 is equal to 1.5, that's why that's the other option. Okay? Now, we just did this question. For which angle, for the next one says, for which angle measures theta is cosine of theta equals 0. So we just talked about that. The cosine equals 0 means we're either at the top of the circle or at the bottom of the circle. So we're either at theta equals pi over 2 or theta equals 3 pi over 2. Now, what are the values of sine of x? Well, that's just the y values. So sine of pi over 2 is 1, and sine of 3 pi over 2 is negative 1. Sometimes we throw parentheses, sometimes we don't. It just is it doesn't really make a difference. Okay? So those are at the top and bottom of the unit circle. Again, have your unit circle out and just make sure you refer to it. And the best thing to do is to pause the video and answer it yourself and then watch me go over it. Okay? Because I'm going through it quickly and it's going to stick a lot better if you pause, try it yourself, and then restart. All right. So tan of 5 pi over 4. So 5 pi over 4 is down here, this 45-degree angle. Down here, both the sine and cosine are the same value. They're both negative root 2 over 2. If you divide something by itself, you're going to get 1. Sine of 3 pi over 2. 3 pi over 2 is straight down here, so that's negative 1. Cosine of 7 pi over 4. 7 pi over 4 is over here. In this quadrant, the cosine is positive and the sine is negative. So the cosine is positive root 2 over 2. Really, that's just looking at your unit circle. You can also type them into your calculator. As long as your calculator's in Radian mode, you're going to be okay. The thing that's a little tricky, though, for example, that third one, cosine of 7 pi over 4, gives me this answer. And we want you to give us the exact answer. So if you see that decimal answer, you've got to make sure you can recognize that as the square root of 2 over 2. That might be a little tricky. So it's probably better for you to just practice using your unit circle. Okay. Question 5. The sine of an angle is 0.6. What is the tangent? Well, I know that if I'm in the second quadrant and my sine is 0.6, that's making a triangle that looks something like this. So the y value is 0.6. And on the unit circle, the hypotenuse is always 1. So the x value is a question mark. So we can say x squared plus 0.6 squared is 1 squared. This is called the Pythagorean identity because it's just like a squared plus b squared equals c squared. And this is really the big idea of the unit circle, is that every point on the unit circle is really just is just created by making a triangle that touches the center. So I just squared 6 to get 36, subtract it to get, 0.64, not 6.4, 0.64. And then take the square root of that and you get x equals 0.8. And when you take a square root, you get plus or minus. Well, which one of those answers is in quadrant 2? Well, the way I drew the triangle makes it clear this has to be the negative zero point 0.8. So the tangent value is always going to be the y-coordinate divided by the x-coordinate because that's opposite over adjacent. So here we have 0.6 over negative zero point 0.8. If you want to reduce that, you can. It's negative 3/4. All right, beautiful. For what angles is the cosine value positive? Okay, cosine is positive when we're on the right half of the unit circle. So 0 radians is good. This is pi over 2. So I know this one's positive here. Now the next one's kind of tricky, 5 pi over 12. But what I know is that 5 pi over 12 is smaller than 6 pi over 12. And 6 pi over 12 is a half a pi. And so I know 5 pi over 12 is kind of like this. It's pretty close to pi over 2. That means it's in the positive half of things. Now 5 pi over 6 is no good because 5 pi over 6 is pretty close to 6 pi over 6, which is equal to pi. And actually, I think 5 pi over 6 is on your unit circle. It's pretty clear if you look at your unit circle, there's a negative x value. 3 pi over 4, no bueno. 5 pi over 3 is good because 5 pi over 3 is down here now, and that's back on the positive side. So I think on this one, 4 of those answers you can just look at on your unit circle. The 5 pi over 12, you need to kind of do a little bit of comparison and recognize that it's smaller than a half pi. All right, moving right along. Wonderful graphs here. When you look at the unit circle, one of the crucial things to recognize is that the beginning point is 1, 0. And what that means is that at 0 radians, the cosine value is 1 and the sine value is 0. And what that means is that the point on the graph here of 0, 1 versus 0, 0 tells you if you're looking at a graph of sine or a graph of cosine. So I can tell here that the green graph that starts up at a height of 1 has to be cosine because the value of cosine at the beginning of the unit circle is 1 and the value of sine at the beginning of the unit circle is 0. The other thing I want you to recognize is that at this point here we have 0, 1, which means that the cosine of pi over 2 is 0 and the sine of pi over 2 is 1. What that means is that cosine is initially getting smaller and sine is initially getting bigger. And that's what you can see here, that the green graph is going down and hitting pi over 2, 0. The blue graph is going up and hitting pi over 2, 1. So the unit circle tells you the coordinates that are on the graphs of sine and cosine. Now we've got a Ferris wheel, our favorite context here. The center is 100 feet off the ground. The radius is 85 feet. A is 0, B is 7 pi over 12, C is 5 pi over 4. Wonderful. Okay, so point A is, and all we're looking at is how high the Ferris wheel is. The nice thing about point A is it's just at the center height. So for point A, it's just 100 feet off the ground. If you wanted to write a fancy equation, you could say that that is 85 times the sine of 0 plus 100. And the reason that works is because sine tells you the y-coordinate. The sine of 0 is 0. So 85 sine 0 is just a silly way of saying the number 0. Now B is going to be 85 sine, and I just lift the angle from the problem. So 7 pi over 2 is why I did that, plus 100. Now 7 pi over 12 is not on the unit circle. I know that it is a little bit smaller than 1. I also know it's a little bit bigger than 0.86. because 0.86 is the square root of 3 over 2 value. So I'm just going to guess as 0.9. And so I'm going to estimate this as 85 times 0.9 plus 100. We can actually get the exact value. 85 sine 7 pi over 12 plus 100. We get 182. Pretty darn close to my estimate. So if you do 85 times 0.9, we get 176.5. So pretty darn close. The last one, value C, is just 85 sine of 5 pi over 4 plus 100. Well, 5 pi over 4 is that negative root 2 over 2, which earlier I mentioned as about zero point 0.7. So we could estimate it as 85 times negative zero point 0.7 plus 100. I'm just going to guess that that's about 30. Let's see what it comes out to be. Okay, I was a little off. 40.5. That's okay. We'll just switch our estimate there. So the important thing is how I set up those equations. The radius multiplies the sine value because you have a bigger circle. It's your scale factor. And the center just lifts it up by adding at the end. So you multiply by the radius, and then you just add the center. All right, we're looking at the unit circle, and we're doing a bunch of rotations. Label these points on the unit circle. Q is the image of P after an 11 pi over 6 rotation. So that's weird. They already have them labeled in the picture. I guess maybe we should try to write what the coordinates are. So we're saying P is 1 comma 0. Q is root 3 over 2 and negative a half. So I'm just using the unit circle to label these. And that's all there is to it. Great. So just make sure you know how to do that, how to label them all. And I think this might be the last one. Yep, okay. So we got a radius of 1 foot. Now the nice thing about the word radius is so read this question. Indicate where the point P will be after the wheel rotates 1 foot. So if I rotate 1 foot here so that this circular length, this arc length is 1, then that tells me actually that this radius, this angle right here is 1 radian. The angle measure of a radian is equal to the length that the point has rotated on the circumference. Similarly, I just answered parts A and B. Indicate where point P will be after it rotates 3 pi over 2 feet. 3 pi over 2 is right here to point R, and that angle is 3 pi over 2. So the point of this question, it's a little bit of a confusing question, but the point of the question is that the length that it rotates is the angle measure in radians. That's why we use radians as an angle measure, because it directly tells us what the length is. So anyway, thanks for watching. Let me know what was confusing. Happy to help out.